The slope is identified mathematically as rise over run. It's the vertical change, or the change in y, over the horizontal change, or the change in x. So when we go from this point to this point, what is the rise over run? Well, it goes up 2, rise, and over 1, 2, 3. So it has a slope of 2/3. And if it ended up being like 4/6 or something, of course you would reduce it, but you always want to reduce it to whole numbers. So this has a slope of 2/3. Whereas this one, here we have a point at 0, 2, and this point is 2, 0. This is going to go down 2 and over 2. Down 2 is going to be a negative rise and over 2. So this is a slope of negative 2 over 2, and we're going to simplify that to negative 1. It's really negative 1 over 1, but we don't care. So this is a slope of negative 1. Now, if you wanted to go this way, if you knew that this point was, what is that point? That is negative 2, 4. Then this is going to go up 2 and backwards 2. Now look what that does. That still gives a negative 2 divided by 2 is negative 1. 2 divided by negative 2 is negative 1. Doesn't matter if you put the negative sign on the top or on the bottom, that's still going to make your answer negative. The only difference is if there's a negative on the top and a negative on the bottom, that makes your answer positive. Your change in y here, all the y's are changing. And your change in x is nothing. All of the x's are the same, there is no change. Whereas here, all of the x's are changing, and y is not changing at all. So I'm still talking about 0. This is a number. This equals 0. However, this means I have broken this pizza up into 0 pieces. You can't do that. That doesn't make sense. This answer is considered undefined. So this line has a slope that is undefined, whereas this has a slope of 0. This is our slope. We have a slope of negative 3 over 4, and we have a point that is negative 3, 2. So we're going to start at our point, negative 3 and up 2. We're going to start there, and we're going to have our slope. Now our slope says we're going to go down 3 and over 4. So we're going to go down 3 and over 4. And there is our next point on our line. And we can draw our line this way. Okay? And then the question is, how fast does he swim? This is the real math question here. You're going to find the slope in a fraction form, and you're going to find the rate. How fast does he swim? Well, we know one point on our graph is 4, 60. The other point on our graph is 0, 0. So if we get from 0, 0 to 4, 60, we're going to count rise over run. How much does it go up from 0? And this is easy to tell. From 0 to, it goes up 60, and it goes across 4. So how fast does he swim? Well, he swims 60 miles in 4 hours, but I want a miles per 1 hour. So I'm going to reduce both of these by 4, and I'm going to get 15 miles per hour. We write the equation in y equals mx plus b form, and this is a formula. And the farther you get in math, the more you're going to have to understand formulas. And science, by the way, but. Okay, y equals mx plus b. Notice you have your x and your y, which can be any point on the line. So we're going to leave those x and y. M is the number we're going to give to our slope. So let's say our slope was 3/5. Then the 3/5 would go right here. B is the y-intercept, and The y-intercept, what that means is where this line intersects with the y-axis. So if this is your line, this point right here is your y-intercept. If this is your line, then that point right there is your y-intercept. Your y-intercept could be down here. Your y-intercept could be way the heck down here if you've got a line way over there. Doesn't matter. Wherever it crosses the y-axis, that's where your y-intercept is. For example, let's say I've got the equation y equals 2/3 x plus 4. This is my slope. This is my y-intercept. I can start here. I'm going to go to the point 0, 4. 1, 2, 3, 4. It crosses the y-axis at 4. And then I'm going to use my slope up 2/3. Poof. I can draw my line just like that. So, the next question, what if your equation is different? What if it doesn't end up being y equals mx plus b? What if it doesn't look like y equals 1/3 x plus 2? What if it looks different? What if your equation looks like 3x plus 2y equals 6? I can't just magically graph this. I want to be able to get this to look like y equals something x plus or minus something. Now, we're going to have to change around the equation to get y all by itself. Now, do you remember when we had in the equation 2x minus 4 equals 12, and we had to solve for x by 2, so it was just x on this side. I want the y to stay here because I wanted to say y equals something. So I'm going to get rid of the x. I'm going to move the x to both sides. So the other side. So I'm going to get rid of it. I have a 3x added to my 2y, so I'm going to subtract 3x from both sides. So now this goes away. And I have 2y equals, and I can't add or subtract these two together. It's like apples and oranges. I can't say 6 minus 3x is 3x. I can't do that. So this should be 6 minus 3x, and I just leave it like that. But I want my x on this side, so I'm going to say negative 3x plus 6. So I've got 2y equals negative 3x plus 6. Now, I can't have this 2 here. I have to divide everything by 2. Now, I'm going to start by actually drawing it. Divide everything by 2. And now fix it. Now I have y equals, and I have negative 3 over 2x, and what's 6 over 2? That's 3. Now, we're going to go backwards. We're going to take the line, and we're going to find the equation. Now, the two things we need to find this equation are where it crosses the y-axis and what the slope is. Because the other two parts are x and y, and we know those. They're x and y. So, we're going to find the y-intercept. Our y-intercept right here for, whoops, nope, we're going to start with this line. We're going to start with this line. Here, it crosses the y at negative 4. And our slope is rise over run. So our next point here is going to be here, 3, 0. So I've got my 2 points. I'm going to start by writing out my equation. Y equals, I don't know m yet, x, and my plus b is actually negative 4. It's a negative 4. That's where it crosses the y-axis. Now I'm going to do my rise over run to figure out my slope, and that is up 4 and over 3. Up 4 and over 3. Now, the word problems on this particular assignment ask you to understand what it is that you're talking about. So let me walk you through one. Lee's house is 350 meters from her friend's house. She walks at 50 meters per minute. That's her rate. The equation y equals negative 50x plus 350 is the distance, and distance is y, Lee has to walk in x number of minutes. You're going to graph it, then you're going to explain what the x and the y intercepts mean. Now, Distance can't be negative, and time can't be negative. So you're not dealing with this kind of graph, you're dealing with this kind of graph, because all of them can only be positive. And remember, time is always on the bottom, distance is always on the side. So she started out at her friend's house, and she's coming home, and it's the distance from her house. So she's going to start far away and go towards her house. Lee's house is 350 meters away, so we're going to start at 350 meters away, and she walks 50 meters per minute. So how far has she walked in 1 minute? When x equals 1, what is y? When x equals 2, what is y? When x equals 3, what is y? And now you can graph your line. And your line ends up doing this. After 1 minute, after 2 minutes, after 1 minute, she's walked 50 meters, so she's got 300 left. After 2 minutes, she's walked 100 meters, so she's got 250 meters left. So you're ending up graphing this. And it gets you all the way down in here. And then they'll ask you to explain what the x and y intercepts mean. And that's the concept part. So I just need you to understand it. The y-intercept here, when this line crosses your y-intercept, that is the total distance she had to walk. When this line crosses the x-axis, this is the total time it took to walk that distance. And then your slope, which is rise over run, is distance over time. So your slope is actually your speed, your rate in meters per minute. Okay? So direct variation means that you've got your y and you've got your x and you have a constant. And what that means is you take your x and you do one thing to it, and you do the same thing to it each time to get your line. So this is a times 4 or divided by 3 kind of thing, always, always. It's not like we've been dealing with. There is no plus or minus b ever. This line always goes through the origin. Y equals some number x. And yes, this is your slope, but there's no ever plus or minus b, ever, ever. This equation, you've got a 2 multiplied to your y. You want y to be by itself. How are you going to fix that? You're going to divide this by 2. You're going to divide this by 2. Now this goes away and you've got y equals something. What do you got? This is actually y equals 1/2 x. Do you see how if I divide x by 2, it's the same as multiplying x by 1/2? Divided by 2 is the same as multiplying x by 1/2. Now, that looks just like that. And I can tell you that my constant is 1/2. How about this one? Can I make this look like this used to look? Well, I'm going to subtract 1 from both sides. And that goes away, and I end up with y equals 2x minus 1. No, this is not a direct variation because I've got one of those, and I'm not supposed to have one of those. So that's not a direct variation. What about these? Here I've got some tables. Do these vary directly? So here's my x's and here are my y's. So what am I doing here? Y is going plus 3, so I've got y equals 3 times x, n doesn't matter. And what do I have to do to get from my answer to this number? Well, 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. So I don't have any number I have to add or subtract. So this is a direct variation. What about this one?